Thank you to Oak Ridge and to Johnny Green in particular for inviting me to be here with you today. I appreciate those of you who came to the earlier presentation and decided to see me again. That's encouraging. And what I thought I would do this talk is really to give you a very broad overview and organizational look at what we do at Georgia Tech research-wise. It'd be impossible for me to describe all the research that happens at Georgia Tech in a one-hour seminar. But I think it'd be instructive just to kind of see how we approach our research mission and see where there are potential ways for Oak Ridge and Georgia Tech to partner and collaborate going forward. So it's one of these mile wide and half an inch deep talks, but hopefully it's going to be somewhat interesting. A little history first. Georgia Tech was founded in 1885, so we're more than 135 years old here, 140 years old. Currently, and those were the first two original buildings when we were founded. Right now we're the largest engineering college in the United States, as was mentioned. And we're in the top 5, if you follow rankings in U.S. News rankings in engineering. Actually, that number should be about 25,000 students across the campus. Engineering's 13,000. 1,000 faculty, another 1,500 almost research faculty, many of those in our Georgia Tech Research Institute. And $771 million in research expenditures in FY15. So that gives you some idea of the size of the enterprise and understanding of why I couldn't possibly do justice to summarizing everything that's going on in one talk. Our strategy basically is discovery, application, deployment of science and engineering knowledge. So this is the Venn diagram that sort of attempts to describe that. We, as a state-funded institution, we have a mission and a responsibility to provide economic development for the state of Georgia and in particular and more broadly for the nation. So we tend to be much more on the applied side than perhaps some others, but certainly do our fair share of basic research as well. We are very interested in partnering and collaborating. One of the reasons I'm here and agreed to do this. We actually already have a very good partnership with Oak Ridge, but we'd like to continue to strengthen that. And we're always concerned about the impact of what we're doing in society and making the world a better place. So this is the big picture look at how we're organized, and if you go from left to right, you can kind of see discover. You can see these 3 bubbles. You can see discover, apply, and deploy as you go from left to right. So we have obviously a president who runs the entire university and an executive vice president for research, and in a loose way, the whole research enterprise reports through that office. The academic part of the campus, the colleges and schools are doing the discovery. Then the application happens through the Research Institute and the the Enterprise Innovation Institute, which is our economic development umbrella organization, which houses our incubator and all of our venture capital activities and commercialization activities. And then finally, on the far right there, you see some of our outreach, our professional education activity, which again is in the deploy space. Down below, there's a description of our interdisciplinary research institutes, which I'll talk more about in a second, but essentially you can think of it as a matrix where the colleges and schools, electrical engineering, et cetera, are the verticals, and the IRIs, or interdisciplinary research institutes, are the horizontal lines. And those IRIs are focused on grand challenge type research activities in energy or manufacturing or materials, or there are actually 10 of them, and I'll show you all 10 of them. And so we have faculty who are active in research in one or more of these IRIs or grand challenge areas, but have their home within an academic unit, which is the typical thing you see at a university. And what else is on here? The other stuff at the bottom is not that important. This line, the Georgia Tech Research Corporation, is kind of just a holding company. Georgia has a funny law that says you can't carry money over into beyond a fiscal year, so you can't sign multi-year contracts. So we need something that will allow us to sign multi-year contracts and do research, right? So that's the corporation. And then the foundation is, as a dean, most of my job, or at least part of my job, is to go out and raise money. The foundation And if you're an alum, raise your hand so I can make sure I get your check before I leave. The foundation is our bank, essentially. So, okay. So I mentioned the IRIs, or research institutes. They address these, or will address these 12 core research areas which we defined after lots of discussion and town halls and retreats and brainstorming. So these are kind of the ideas that emerged after quite a bit of thinking and activity. They map almost one-to-one to these IRIs. There's 12 ideas here, but only 10 of them have been functionalized or stood up as IRIs thus far, but the other two are coming. You know, a lot of that is resource dependent, right? So I think the ones that are of most interest perhaps to Oak Ridge, data science and engineering certainly, electronics, nanotechnology, energy, manufacturing, materials, national security. Could be others on that list, but I think there's many different touch points that could be relevant. Now those map loosely to the National Academy's Grand Challenges, which I've just listed for you. There's 14 Grand Challenges which the Academy published 3 or 4 years ago, maybe 5 years ago, that are facing society. And those 14 challenges fit almost into 4 buckets, main buckets, which I've labeled energy sustainability, security, human health, and infrastructure. So you can think of these are the things that are the challenges that are facing human society that if we find the solutions, we'll be much better off, right? So these are the things that the Academy thinks are the most important pressing needs that engineers and scientists need to solve as we go forward into this new millennium. So you could think of our priorities as looking at these grand challenges and finding a way to organize ourselves in such a way that we are doing impactful research that addresses these grand challenges through these interdisciplinary research institutes. What else is there? Yeah, a lot of that's just words, but basically that's what's going on. So here are the institutes, and you can see there's a pretty close correlation between the 12 ideas that we decided we wanted to be known for or work on and these IRIs that have been stood up thus far. So again, the most recent ones are at the bottom, I believe, or close to it. The most recent ones that we've just stood up, there at the bottom, the Institute for Information and Security and Privacy, basically information security is the general theme. That was recently announced a few months ago, and one that's coming very soon in the next few months, the Institute for Data Science, Data Engineering and Science, which if you take out the 4, has a nice, cool acronym, IDEAS, right? So, so all of our ideas will come out of this institute. But those are the ways that we've organized ourselves research-wise, and our touch points for the external world, and partnering, and our ways to organize facilities and to go out and gather resources. It's important, as I mentioned earlier, our mission is to be an economic development engine. Our motto is progress and service. So industry collaboration is a key. And you can think of that as not just industry, but you can think of collaboration with entities like Oak Ridge is also part of this equation. So we like to think that we are good at establishing partnerships that take us from the bench to commercialization. We think we're responsive and connected and accessible, and we think we're easy to work with. You'd have to tell us if you agree, or the company partners have to tell us if they agree, but we think we are. We give our partners access to some of the very best students in the country. I mentioned earlier that our undergraduate students were recently called the smartest students at any public university, and there was some quantification of that, so you have to believe it. I think our graduate students are pretty good too. Obviously doing cutting edge research. If you have a $770 million research enterprise, you're doing cutting edge research. We have a startup organization. I mentioned the incubator. It's called Venture Lab, which is part of a statewide network of incubators called the Advanced Technology Development Center. But the idea is Our faculty, research faculty and academic faculty have access to seed funding and space if they want to do a startup. And the organization also helps to connect them with funders, with venture capitalists, angels, whoever might be interested in funding, all as a part of within the confines of the university. We've been spinning out approximately 10 or so companies a year for the past, a decade or so. And some of those companies have been very successful, like you've probably heard of Earthlink. That was a Georgia Tech. That wasn't the original name, but it eventually became Earthlink. Some have had big exits, like there was a company called Internet Security Systems that was developed by one of our alums. His name was Chris Klaus. He developed the basic technology for this internet security apparatus in his dorm room between classes, I guess. The company was sold to IBM for $1.3 billion. And so Chris is one of my favorite people that I visit frequently. And then there are companies that didn't do as well, but also contributed to sort of the ecosystem and the campus environment and the innovation that's going on around the campus. I'll say more about that in a second. So partnerships are really important. If you look at it and around our campus in Midtown Atlanta, you'll see not just the university itself, but you'll see innovation centers that we call them that have been stood up by some of our corporate partners like AT&T and Panasonic and Home Depot and Georgia Power, and et cetera, et cetera. So basically the model is the company comes, opens up an office, usually a relatively small number of people, 20, 50 people, in an R&D-like laboratory, but the proximity to our campus gives them access to the student and faculty talent and also the knowledge that's coming out of the university. And so there's a nice partnership that evolves organically because of the proximity. And about a dozen company partners have done that thus far, and we expect that number to grow. And that's kind of one of the directions we're heading into the future. Also around this slide, you'll see around this picture on the slide, you'll see a few academic activities. Focus on one, TIGER. TIGER is an acronym that stands for something I always forget, but the basic idea is we partner up an engineering PhD student or science PhD student, a law student from Emory or Georgia State, and then a business student from our Scheller College of Business. And that three-person team, and sometimes there are a few more people, works on commercializing the PhD student's research. And this is a pretty unique model that has gotten some national awards, and the company has started some companies that have had some degrees of success. So that's at the graduate level. I'll say a little bit more about what we're doing at the undergraduate level to foster this innovation from our research in a few slides. But there are also some government agencies around here that we're partnering with, State Economic Development Office and various other places that are interested in our research progress. So these innovation centers is a bigger description or at least more pictures of these innovation centers. This is something that's worked pretty well. I think AT&T was our first one. That could be right. The AT&T Foundry. It's right across the street from our, right in the same area of Midtown Atlanta as our hotel and bookstore and business school. But it's worked well enough that other companies pictured around here, Home Depot, Panasonic, ThyssenKrupp, a few others have done the same thing. And we think this is sort of a good model. And you might think of this if you're familiar with Cambridge and MIT, et cetera. Kendall Square is probably a good analog for this kind of thing. So this is the Kendall Square of Atlanta, if you will. Let's see. The next few slides are just a few examples that can give you some idea of what's happening in some of those big picture buckets, those energy, life, human health, infrastructure, and security buckets. In the energy area, one of our chemical engineering faculty members, Crystal Walton, got a big Energy Frontier Research Center, EFRC, that does work in acid gas-induced evolution of materials for energy. She was one of, I think, the first cohort of these EFRCs, or maybe the second cohort of EFRCs. These are big awards, $10, $11 million over, I think a 5-year period, and we're certainly very proud of Krista and her work. She's relatively young faculty member doing really nice research and reaping the benefits there. Sustainability, a couple of examples, or maybe there's one example. Kostas Konstantinidis in civil engineering, and Eberhard Voigt, who's a biomedical engineer, and Jim Spain, who's also a civil, got a $2 million grant or so from NSF to do biodiversity, looking at microbial systems and their diversity. I put this on here to illustrate teaming of people from disparate disciplines is a very common thing. There are very low barriers to collaboration at our place, so it's not unusual to find folks from all across the campus working on a problem, despite where their home institution is. And that even extends to students. I'll have an electrical engineering faculty member advising a chemistry student PhD thesis. So I think that's a sign of a healthy research environment that's able to tackle the problems that we need to tackle. Human health, here's another example from that bucket. Both Garrett Stanley and Craig Forrest were part of the big announcement of the brain initiative that they had at the White House, I think, a couple years ago. And they're both doing really seminal work, I think, in understanding how the brain works and mimicking and modeling that functionality. So Garrett does work in understanding sensory systems and the adaptation of sensory neurons, and it helps discrimination. It helps determine how the brain discriminates between different stimulants. Craig is doing some work in a robotic system that does whole cell patch clamping, which helps the throughput of intracellular studies. So it helps help make these characterization studies more efficient and effective. Cybersecurity, it's another big area for us. Rahim Baya does work in wireless cybersecurity, doing some digital fingerprinting and other similar work. You can think of this as sort of determining a digital DNA for a device or class of devices, and making those devices resistant to threats. And then some work here, Vince Mooney, both of these are electrical engineering faculty, finding ways to find signatures for malicious hardware and prevent intrusions. Infrastructure. So this is flexible electronics. This is one of these national, what do they call it, NNMIs, these big manufacturing institutes. NNMI is an acronym. I can't remember what it stands for, but there are several of these institutes that that NIST has been leading the formation of, but all the federal agencies, I think, contribute to these. The one we are actors in, or participants in, I think 3 or 4 of them right now. One is in flexible electronics, where we have a leadership role. Professor Sudaraman here from mechanical engineering, and also faculty from ECE, MSc, and industrial engineering, working on ways to do organic flexible electronics, which have applications in wearables and other areas, and some very exciting work going on there. We need facilities to do this stuff, so we're always interested in where we're going to put this activity. The newest building that we just opened up in the August of last year was the Engineered Biosystems building. This is about a 250,000 square foot facility that has the headquarters for biology, and then half of it's biology, the other half is biomedical engineering and chemical engineering. The research themes are synthetic biology, systems biology, sort of the computational stuff, and cellular engineering, so tissue engineering, stem cells, cell manufacturing. This was the most expensive building we ever built. It was, I think, $113 million was the price tag. We're in a fortunate situation that the state often helps us with these kind of things. The state gave us $64 million of that $113 million, and then they told the deans to go raise the rest. So that's what I've been doing for the last couple of years as a part of our capital campaign. But the building opened, as I said, last summer. It's now 80% paid for. The remaining 20% is pledges that we've acquired through philanthropy. So it'll be paid for after everyone pays off their pledges, right? So that's pretty impressive to have a building of that magnitude fully financed in such a short period of time. Let's see, so the next big project, which I've said a little bit about to folks in various meetings today, is our high-performance computing center. There could be some interest in partnering here. Certainly, Oak Ridge has much interest and activity in high-performance computing. This is, if you know our campus, this is kind of across the street from our hotel. There's this historic building called the Crum and Foster Building. For some reason, architects like historic buildings, and you can't tear them down. So we had to sort of leave this funny-looking old building as a facade for our big, high 25-story tower that's going to go in the back. My apologies if you like historic buildings. I'm sorry. When it's said and done, this will probably be our next most expensive building we've ever built, as is every building we build now. But the idea is a data center, about a 4-story or so data center behind this older building, and then this I think it'll be 22-story tower. The model will be, it'll be about 700,000 square feet total, 350 Georgia Tech, the other 350 industry partners. So we're actively courting industry partners to co-locate with us to look at research areas that impact either directly use or directly in improving computing or using high-performance computing for various other applications in data science and analytics, and you can think of the list of relevant topics. So this will be somewhat unique. We've not done this before. We've had industry partners directly co-located in the same facility. We've had incubators and things like that, but those are sort of separate from the main academic buildings. So we'll see how this works. This is an experiment, and we've got a list of folks we're talking to, and I think so far it looks like it's going to have some traction. By the way, we haven't even started on this building yet. We break ground probably later this year, summer probably. And it's a 3-year build, so you can think 2018, 19 is when it'll be finished. I wanted to say a little bit about research and innovation as it impacts our academic enterprise and particularly our undergraduates, because I think that's important and a differentiator for us. So there's lots of examples of what we do to get students sort of engaged in not only doing things like undergraduate research, but how does that undergraduate research have impact and potentially be commercialized. So there are various student innovation programs. They have all these acronyms that don't mean anything to most people other than us, people at Georgia Tech. One that I will just highlight that I think is pretty cool is our newest one. It's called CreateX. Let me make sure I don't have a slide on CreateX. I may have one. No, I don't. So CreateX is a program where undergraduates in 3 phases. The phases are called Learn, Make, Launch. Think about what they learn in the classroom and how to start a business from that. So learning is, how to write a business plan, intellectual property, customer discovery, all that's done in a classroom environment. Then they make something. They may make a prototype or a program or a process that has commercial value, and then they consider launching a business. So we actually, through a generous donation from an alum, have a mechanism so that these students can basically intern or co-op for themselves, for their own company in the summer, trying to develop this idea for a business. So far we've done 30 or so of these, and 8, I think this is right, 8 are still active, have gotten rounds of funding and are trying to, grow their businesses. So when we get to steady state, we think this could be as many as 100, even more student companies coming out every year. Now, why were we doing this? So many reasons. One, most of these 100 or 200 companies will fail, and that's okay, we understand that. But it's a safe place to fail, right? Because you're still in school and you haven't, sold all your possessions. And I have many conversations with parents who their son or daughter has this idea and they want to drop out of school so they can go develop our idea. The parents don't like that. I wouldn't like that as a parent. And so I'll have less of that to do now because they have this internal mechanism where they can try this out. And then also, the selfish part of it is, some of these companies are going to do well, and I'm going to go back and knock on doors and ring doorbells of these successful entrepreneurs and ask them for their support, right? So it's enlightened self-interest here. And what else will I say here? I think I've said a lot about some of the other stuff on here, but there's also various, in addition to CreateX, there's various competitions and things that students get involved in. One that's sort of cool is our Adventure Prize competition, it's called. And if you've seen Shark Tank, everybody. So the students, this is like Shark Tank, and the students call it American Idol for Geeks. The idea is we start with 600 or 700 students, and they have teams, and we narrow it down to 6 finalists, and the finalists get to present their work before a panel of judges at one of our venues. It's public. It's on public television and live TV. So Georgia Public Television televises it for us, and the winners get $20,000 prize, and we patent their device, and they get launched into our startup accelerator, which is called Flashpoint. Second prize, I think, is $10,000, and third prize is there's a what's it called? It's called audience. We vote on our smartphones for our what's it called? The People's Choice Award. That's what it's called. So the People's Choice Award gets $5,000. So people that are in the audience can vote for their favorite on their smartphone, or at home, the home audience can vote too on their phones. And so it's pretty cool. The students love this. It's getting bigger and bigger every year. This year, for the first time, it's expanded to. There's going to be, the ACC basketball tournament. There's now going to be an ACC Adventure Prize tournament, which we are coordinating and sponsoring. So I don't know if it's going to be on television like this basketball tournament is, but but students are excited about it. So these are a couple of the winning teams from recent years. These ladies developed a economical, efficient, energy-efficient toilet, essentially, for developing nations. And their marketing tagline is "Everybody poops." And then Partha here developed a more ergonomic crutch. And that ergonomic crutch, which relieves the stresses on the joints and makes it easier to walk with it if you're walking with crutches. He's actually in active manufacturing and marketing now. Got a recognition at the White House, so Partha got to go meet the president as well. So just a few statistics. We're highly ranked at Georgia Tech in worldwide, however you want to measure research. This is universities granted patents. We also are high on the list of invention disclosures and undergraduates participating in research. Another one that's not up here, I think this number is right, about 40% of our patents that we write have a student author, student co-inventor on them, which is pretty cool, I think. So some trends that we think are positive: more and more and larger awards, more shared use, sponsors living with us, I mentioned that, actually cohabitating or co-locating with us, and student entrepreneurship. I'll end with some themes that could be of interest here that could be potential partnerships. Talked about materials, some work in carbon fibers done by Professor Kumar, material science. I talked about Raheem earlier, who does the wireless security stuff for network infrastructure. Some work in chemical engineering, Chris Jones on energy efficiency, and I'm sorry, he does separations. So for carbon capture. Boyan is one of our nuclear faculty. Just had a really good meeting with Alan Eisenhower about the nuclear work that's going on here, so there could be an opportunity to collaborate there. He works on reactor design, fuel cycle waste management, and then finally Moin Qureshi does computer architecture for high-performance computing applications. So lots of stuff going on that there could be some collaboration. So, I think the possibilities for partnership are pretty deep and broad. We know that some of the expertise here in these various categories matches and maps very well to some of the work that's going on in engineering at Georgia Tech in the various disciplines. So I hope that my visit here won't be the last time we talk about this, and we'll have opportunities to think about collaboration going forward. I think that's my final slide, so I'll be happy to take any questions. Yeah, Tom.
So if you look at, the path that Georgia Tech has gone on, say, since you were an undergrad in the early 80s, and, really pretty remarkable progress as an institution. Mm-hmm. And of course, in parallel with that, Atlanta has been, on a pretty steep growth curve as well.
Right.
I'm kind of curious about the interaction between the two in the sense that I'm sure there's a lot of Atlanta in Georgia Tech, but there's probably a lot of Georgia Tech in Atlanta in terms of, where things have really prospered and grown. Can you see the fingerprints of the institution in the city and vice versa?
More and more. I mentioned this area of town in Midtown Technology Square. That used to be a very, underdeveloped, not developed at all area, depressed area, a crime-ridden area, where we decided to build, expand our campus into the Midtown area of the city with the city's blessing. And that's opened up a lot of opportunities. So that's why these companies are beginning to come to the state and come to the city and locate in and around Atlanta. We have active collaboration with the mayor's office on a variety of things. As an example, we had a problem in the city with waste management. Sewer systems were old and decaying and needing some work, and the mayor came to us to see if we could do a study that would help inform and make some recommendations on how to do that from a technical standpoint, but also efficiently and cheaply, et cetera. So we have more and more of those kind of collaborations with the city. Also on the education side, lots of activity with K-12 in the high schools and even below high schools in the Atlanta public school system. For us it's recruiting, but it's also STEM education and enlightenment which benefits the city and the state beyond just the Georgia Tech benefit. So many things like that. I think there could be more and better, but it's evolving and growing. Yes. Yeah.
You have articulated a very compelling vision of how you interact with industry.
Mm-hmm.
And the bottom line is that you're easy to work with.
We think so.
And of course, the reputation of many universities in the IP area doesn't
Right.
match that. What have you done differently?
So I think it's more of a philosophical change. I think many universities kind of get caught up in, well, there's two problems. One is a lot of the tech transfer or licensing offices are thinking that they want to make sure that if they develop the next Gatorade, that they're going to get all those economic benefits. Those kind of successes are very rare and few and far between. Not that they don't happen, but they don't happen. So we've taken the philosophy that let's hit singles and not home runs, right? The other piece is many of those same technology licensing offices are much more interested in compliance than they are in business development. So they'll make sure we don't violate the Bayh-Dole Act and all these kind of legal ramifications, which obviously we don't want to violate any laws either. But I think we take the posture that it's better for us if we may miss out on some resources on the front end as we negotiate these agreements with companies, but we think we get it back on the back end, because if the company is successful, they'll keep coming back to us, and more importantly, our graduates will go to work there or go to do things themselves, and we'll get it back in terms of philanthropy and various other ways. So if we are not so obsessed, if you will, with what I call low probability events that lawyers worry about, then we can have more friendly environment for industry collaboration. Yes.
You mentioned the Tiger program.
Yes.
Actually, my daughter's an Emory Law student. She's involved in that.
Good.
But I thought it was merely an educational experience. I didn't realize she was trying to do a startup.
Well, it can stop with the education, but many of the groups try to keep going and commercialize. They enter business plan competitions and move on. So your daughter may have decided that she's just going to get the educational benefit out of it, or she just maybe hasn't told you yet that she's about to do a startup. but several, and I've had several of my PhD students do Tiger as well. I think the majority of the students, it is just the education piece, but some have actually gone out and raised some money and done some business. Yeah, Johnny.
So you talked about with some of the students things that you've done to allow them to fail early or fail in a safe environment.
Right.
But quite often, more senior, experienced researchers, the word failure and safe don't go together.
Right. Right.
So in terms of the atmosphere at Tech with the senior faculty, can you talk a little bit about some things you've done to try to, spur innovation, while mitigating concerns about failing?
Well, one of the things we've done is we explicitly recognize intellectual property development in CVs as we evaluate tenure and promotion cases. So that was done, actually, I think it's fair to say I was one of the first department heads or school chairs to do that. And I think and now all of us do it. Not that we think you can, as an academic, you can't base your career on that, but it certainly is something that we evaluate in a favorable way as part of your scholarship. I think that's had an impact. I think also just having the incubator there on campus and showing them that there are some resources available. You can get, I think, up to $100,000 in seed funding and 3 years of infrastructure space, office space, lab space before you graduate. I think that's attractive because you don't have to go out and try to find all these things on your own. You can actually use the state resources the university has for your idea. That's what I think has been most impactful, those kind of things. Yes?
Two questions. One of them, I noticed on your slides, you have that 33% of the undergraduates are involved with research
Correct.
projects. I was wondering, is there a conscious effort to try to, when you go out for grants, to include undergraduates as well as
Absolutely. Yeah, in fact, the question was, do we consciously try to get undergraduates involved in research? And absolutely, there's two things going on. One is we wrote a plan almost 10 years ago now. Part of our accreditation process requires us to write a quality enhancement plan, which basically is what are you going to do new to invigorate your educational enterprise. And one of the things we did in the plan that was written 10 years ago was we're going to focus on undergraduate research, so that was intentional. So the president put some money aside. The faculty were made aware of all these opportunities like NSF has. You can write supplements to your NSF grants. That if you want to add an undergraduate to your project, it's pretty easy to do. It doesn't even go to peer review. The program officer makes the decision pretty quick. So we all actively do that. I mentioned I didn't mention in this talk, but we have a variety of research experiences for undergraduate sites on campus, and these are groups of 10 to 20 to 30 students that we bring in from around the country to spend the summer typically working on campus and doing undergraduate research. So it's become part of the culture as a result of all these different activities.
So that one other question was, contrary to, well, not contrary, but maybe different from some of the presidential campaigns where the country is pretty much taking a nosedive. With your work, as you said, you're going around and actually looking for people to invest in the university. Do you get any anecdotal sense of what over the last some years, what the country is doing? Are we, I think there was an article by somebody in the Atlantic magazine saying, of course, it's the opposite. I was wondering, what is your sense of companies willing to
Support research?
support research and put money into it? It should have some indication of where the country is going 10 years
Yeah, that's a really good question. So as we know, federal funding for research has been declining in recent years. So many universities have turned to various corporate partnerships as a way to mitigate that. I think we've had some success. A lot of the problem has been, as Jim mentioned, the intellectual property issue is a big one. It's not completely solved. I don't want to give that impression. But there's certainly interest among the companies. Even the companies themselves have, the Bell Labs and all those type of organizations are gone. There's only a few companies that have big research activities, at least basic research. So they recognize they have this need too, so there's an interest in partnering with universities for filling that gap. So we're trying to take advantage of that interest. Roger.
So you mentioned some of the focus on cross-disciplinary research.
Mm-hmm.
And some of the low barriers to making it happen. And I guess my question is, chicken versus egg, was it more of a top-down where you instituted some of the IRIs to kind of help drive that
Yeah.
cross-disciplinary, or was it more of organic where it just made sense to make the IRIs because it was already there?
Yeah, that's a great question. I think it was both. So the things that eventually became IRIs, some of them already existed, the idea of having an IRI. So like the Institute for Bioscience and Bioengineering predated this IRI phenomena. And that was organic. That was faculty getting together with similar interests, wanting to co-locate, use the same core facilities and share them for efficiency. And so that kind of became the model or standard for others that followed. So, and then the top-down part was, hey, this Institute for Bioengineering and Bioscience thing is working. Let's see if we can do that in the energy area or the materials area or the manufacturing area. So, so I think it's a pretty healthy way to do it. So it wasn't like forced upon the faculty. Actually, you can't force faculty to do anything, right? As I've learned in the last 5 years. People think I have 400 faculty working for me. I actually have 400 bosses. So the organic part has to be a part of the equation, because you can't, basically what you do is incent the researchers by putting facilities together for them to use, like this EBB building, and having low barriers to collaboration and recognizing these contributions when you do promotion and tenure.
Okay, well, if there's no more questions, then
Thanks very much.